Greetings and welcome to lecture 4.7, Square Roots in the Pythagorean Theorem. So in this lecture we're going to talk about square roots as well as calculating diagonals of triangles, right triangles, which is the Pythagorean Theorem. For example, let's pretend that this is a side profile of a roof line, and so you have your house down here and you have your rooftop. If I know that my distance to the middle, from the tip of the roof to the middle of my house, is 12 feet, and the height of the roof is 5 feet, from geometry, this gives me the equation d equals the square root of 12 squared plus 5 squared. This marker is called the square root symbol, and we'll talk about that a little bit more. So let's just do the math here. D equals the square root of 144 plus 25. Well, 144 plus 25 is 169. Now what this square root marker means, the square root symbol says what number can I multiply by itself will get me the number that is showing. So what number multiplied by itself will get me 169? Well, 13. So 13 times 13 will get me 169. In other words, 13 squared. Now what happens is that this square root symbol is the opposite of squaring, just like addition is the opposite of subtraction, multiplication is the opposite of division. And if I multiply and divide by the same number, I get back to the original number. If I add and subtract the same number, I get back to my original number. Well, if I take the square root and I square a number, I get back to my original number. My original number is 13. So my answer is 13 feet. So that length of diagonal is 13 feet. So the definition of a square root is the positive number a, written as square root a, is the number that we square to get to a. So if a squared equals b, then b squared equals a. And you can rewrite it as the square root of b squared equals b. Again, remember, the square root cancels our squaring and we're only left with b. Let's look at a few square roots. So the square root of 0 is 0. Why? Because what's inside here is 0 times 0. So if 0 squared, we take the square root, it's 0. The square root of 1 is 1. Why? Because 1 squared equals 1. The square root of 4 is 2, because 2 squared equals 4. Square root of 9 is 3, because 3 squared is 9. The square root of 16 is really 4 times 4. And therefore, the square root of 4 times 4 is 4. 25 is 5 times 5, so therefore the square root of 5 times 5 is 5. So it's 5 squared, right? So remember, I'm going to say it again and again and again, the square root cancels out the squaring, so we're left with the original number. You just have to kind of figure out what that original number is. Let's run through some examples on how we can use our square root. 7 square roots of 64. Now 7 square roots of 64, there's an implied multiplication. Just like if I said 7 x's, there's implied multiplication there. So 7 square roots of 64 is really 7 times the square root of 64. The square root of 64 is really an 8 times 8 in there. So the square root of 64 is 8. So 7 times 8 is 56. Let's simplify the square root of 9 plus the square root of 16. Well, the square root of 9, we can write that as 3 times 3, 3 squared. And 16 is 4 squared. Therefore, the square root of 9 plus the square root of 16 is 3 plus 4. And that equals 7. Let's simplify the square root, the whole thing, of 25 over 81. Now personally, I like to break up, when it's a fraction like this, I like to work with it one at a time. So I actually break up this big marker and give both the square root to the numerator and to the denominator. So the square root of 25 will be 5, because 5 squared is 25. The square root of 81 is 9, because 9 squared is 81. So our final solution is 5/9. Another example, 12 square roots of 25. Again, it's implied multiplication. So 12 times the square root of 25. Square root of 25 is 5. So 12 times 5 is 60. And let's simplify the square root of 100 minus square root of 36. So you always have to ask yourself, what number squared equals 100? Well, that would be 10. 10 squared equals 100. What number squared equals 36? That's 6. So square root of 100 minus the square root of 36 is 10 minus 6, which equals 4. One more example. The square root of 49 over 21. Again, I like to break it up. So the square root of 49 divided by the square root of 121. That will give me the square root of 49 is 7 times 7, so the square root of 49 is 7. And the square root of 121, well, that's 11 times 11, so it is 11. So 7 over 11. Now, all of these examples, we used perfect squares. And again, what I mean by a perfect square is when I take the square root, a whole number comes out. That is a perfect square. But all numbers aren't perfect squares. So what about something like square root of 7? Well, it falls between the square root of 4 and the square root of 9. And any number that falls between the perfect squares, because the square root of 4 is 2, the square root of 9 is 3, anything that falls in between, it's actually an irrational number. It's not that I'm just going to get a decimal number. It is a decimal number that never repeats and never ends. It never stops. They are irrational numbers. So as the square root of 7 falls somewhere between the square root of 4 and the square root of 9. And I bet you anything, it's closer to the square root of 9. Because 7 minus 4 is 3 and 9 minus 7 is 2, so it's going to fall somewhere closer. So I would say it's over 2.5. So since the square root of 7 is an irrational number, all we can do is approximate what the square root of 7 is. So let's approximate the square root of 7 to the nearest tenth. Well, like I said, I knew it was over 2.5, so let's try 2.6. 2.6 squared is 6.76. That's pretty close to 7. Let's try to the nearest hundredth. So I'm going to say 2.65. Well, 2.65 times 2.65 is 7.0225. That is a lot closer to 7. Let's go one more digit. 2.646. Well, 2.646 squared is going to be 7.001316, even closer to 7. How about 10,000th? 2.6458 squared is going to give us 7.00025. 764. Very close to the square root, or very close to 7, but still not exactly 7. We will never, ever hit 7 because we will never find an exact value for the square root of 7. Remember, it's irrational. So when we don't have a perfect square, all we could do is use a calculator, and you will be using a calculator in this section, and getting an approximation to the solution. So let's give a decimal approximation for the expression 5 square roots of 12. And we want to be accurate to the nearest 10,000th. So using a calculator, I'm going to approximate, and that's what these squiggly marks mean, approximate the square root of 12 as 3.46411016. Now, using this number, 3.46411016, I'm going to multiply it by 5, and I'm going to say 17.320508. And that's just using a calculator. I'm going to be accurate to the nearest 10,000th. Well, this is 10, 100,000, 10,000, so I'm going to look at the 0, which is lower than 5, so I'm going to leave the 5 alone. So I am, 1, 2, 3, whoop, it is going to be approximately 17.3205. So let's take another example. Again, you're going to use your calculator quite a bit in this section. So let's approximate the square root of 7 over 11 to the nearest thousandth. Well, using the calculator, we can approximate 7 over 11 as 0.63636363. Now, if I wanted the exact solution to 7 over 11, it would be equal to 0.63 bar. Right? But I can't put a bar in my calculator, so I am going to try and use 0.636363, and that should give me enough digits to use my calculator, get the approximation with the square root of 0.63636366. That gives me approximately 0.7977240. And using my rounding, I'm going to round to the nearest thousandth. So I look at the 10,000 spot. It is a 7, so I round up. So my approximation is 0.798. So that's the end of part 1 of this video. So until part 2, be seeing you.